All right, you guys, let's continue our discussion of linear equations by talking about how do we solve word problems. So, a lot of us don't like word problems because we get lost in the words. But if you have a plan before you even begin the problem, it can make solving the problem a lot easier. So, I'm going to walk you some of the steps that I suggest that you do anytime that you're given a word problem that will hopefully make solving it easier for you. So, step one is to understand the problem. Makes sense, right? If you don't understand the problem, then how can you ever attempt to solve it? So, some of the things that you want to do is you want to read the question or the questions first, and then make a note of what it is you are to find. Okay. So, are you looking for how big something is? Are you looking for how small it is? Are you looking for time? Are you looking for a quantity? Keep all of that in the forefront of your thinking. The next step that you want to do is you want to read the whole problem. And if you can, underline the keywords. Okay. So keywords like distance, temperature, things like that to see what you're looking for. And then C, if possible and useful, draw a picture or make a table if you have to, just so that you can organize your thoughts and the information that you've been given. Now, step two, you're going to plan your solution strategy by searching for a formula or using the keywords to translate the words into an equation. Okay, so depending on the type of problem you're given, are you looking for area? Are you looking for distance? Some keyword in there should kind of allude you to the plan that you should make. Now, step three is to execute your plan by solving the formula or the equation. So whatever you decided in step two that you were going to do, try to see if you can execute it. And then four, you're going to attempt to answer the question. Now, the last step is probably the most important. You're going to check your results. Because you're dealing with a word problem, you always have to make sure that the answer that you have makes sense in the context of the problem. So, for example, if you were talking about time and you got a negative answer, we don't count time backwards or negatively. So that would let you know that either your plan was flawed somewhere or either your execution was flawed somewhere. But that's your key to let you know that maybe you should go back and check your results. Okay? So let's look at this word problem. Okay, so the question says a clothing store has a special sale with every item discounted 40%. If the price of a dress after the discount is $24.50, what was the original price? So we did step number one. We read the whole problem, and what we're going to do is we're going to make note of what we're trying to find. So if we look at our problem, we are trying to find the original price of the dress. That is what we've been tasked to find. Okay? So if we walk ourselves through those other steps, the next thing that we would want to do is underline the key words. Well, one of the phrases is every item is discounted 40%. So discounted lets you know that it's less than what it was originally priced for. Okay. The other key phrase in the problem is that the price of a dress after the discount is $24.50. So we know how much the dress has been discounted, and we also know what is the price after the discount was applied. Okay. So now we're going to try to make a plan. So since the discounted price of the dress is $24.50, if we add 40% of the original price to the discounted price, this will give us the original price. So after we've kind of articulated a plan, we're going to try to write that into an equation. Okay? So our plan said that this is our price, the $24.50 is the price of the dress after the discount was applied. And we know that there was a 40% discount applied to the original price. Now, the important thing is that when you're dealing with percents, you always want to change them to decimals first. So this 40% in this equation, that's how we got 0.40, okay? Because we changed it to a decimal. Percent means out of 100, so 40% is 0.4 as a decimal. And then we let our variable P stand for the original price. We let a variable stand in its place because we don't know what the price is yet, so we put a variable as a placeholder. So now that we have this equation, this is a linear equation, okay? So we just learned that linear equations, the highest degree or power that we have is 1. You can see on our variables, we don't have any exponents higher than 1. So this lets me know this is a linear equation. Okay, and I can solve this how I normally would, which means that I need my variable to be isolated or alone on one side of the equation. So I moved all of my p's to the right side, okay, which gave me 0.6p equals 2450. And I need p to be by itself, so I divide both sides of my equation by 0.6. And my price turns out to be 40.83, okay? Now remember, the last step of our word problem strategy is to always check to make sure that your answers make sense, okay? So if we were to take 40% off of our price, which we said now is $40.83, we should get the sales price back of $24.50 that we originally had. Okay, so if we take 40.83 minus a 40% discount of that price, we get 24.498, which rounds to $24.50. So this lets us know that the answer we got is correct, and it makes sense in the context of our problem. Okay, awesome. All right, let's look at another word problem. All right, so remember, our first step is to read the problem. So it says, Lori owes the business office $500. After discussing her situation with a staff member, a payment arrangement was made. She has to pay $25 every month until the debt is paid off. The linear equation that best represents this scenario is given by y equals 25x minus 500, where x is the number of months and y is the amount of money owed. Okay? So A says, how much does she still owe 10 days after the arrangement was made? Okay. Well, let's read our problem first. Okay. And let's go back and highlight any key information. So what we know from the beginning, Lori owes the business office $500. So that's important. She says after she discussed her situation with a staff member, she made a payment plan. All right. And she agreed to pay $25 every month until the debt is paid off. Okay. And then they came to this equation. Okay. So in part A, it says, how much will she owe 10 days after the arrangement was made? Well, we know from our problem that Lori isn't going to pay any money until a month has passed. She made a monthly payoff plan. So in 10 days, a month hasn't passed yet. A month, if we use a standard number, is typically anywhere from 30 to 31 days and 29 if you're in a leap year. Okay, so in 10 days, a month hasn't passed, so Lori owes the same amount of money she did in the beginning. So she owes $500. Okay. Now, as a coordinate, okay, because this is a linear equation and it represents a line, our two variables in this problem were x and y. So if we were to pair that data in a coordinate, x would be the number of months and y would be the amount of money owed. So if we wanted to represent our equation as our answer, as a coordinate, okay, if time passes, we have 0, a month has not passed yet, and she still owes negative $500. So you can think about her being in the hole $500, okay? Now let's look at B. B says, how many months will it take to pay off the debt? Okay, so what does it mean to pay off a debt? Well, that means you don't owe anything. So if we wanted to solve that in our equation, that means that the amount of money owed should be 0. So in our equation, amount owed is equal to y. So that would be 0 equals 25x minus 500. And if I wanted to solve this equation, my goal would be to get x by itself. So I'm going to add 500 to both sides of the equation, which is going to give me 500 equals 25x. And then to get x by itself, I divide both sides of the equation by 25. And when I do that, x equals 20. So if Lori decides to follow her plan to make monthly payments of $25 each month, it will take her 20 months to pay off this $500 debt, which would be almost 2 years. Okay, so x equals 20 months. Cool. I hope this makes sense.